Alright, let's continue with this video will be on solving equations that involve circular functions. So here as an example we have a sine of theta equals 1/2 and we need to solve for theta, and we restrict theta to be between 0 and 4 pi. Do remember in the last exercise we're looking at graphing the two functions, sine and cosine. So let's do that with the sine function. We'll need to start with the Cartesian plane. On the horizontal axis it will be our theta angle. We'll go from 0 to 4 pi, and the function is sine of theta. Remember the period of that function is 2 pi. So from 0 to 2 pi we get the first cycle, and from 2 pi to 4 pi we get the second cycle. At the same time, from the equation we're going to draw the function or the straight line y equals 1/2, which is a horizontal line that's crossing the y-axis as 1/2, and you can see as it intersects the red function at two positions, 1, 2, 3 and 4. Did I say 2? Sorry, 4. It's 2 per cycle. Because you have 2 cycles, it's 2 and 2. The first solution is, remember your exact values, is pi on 6, as sine of pi on 6 is equal to 1/2. So we get that first value. That second solution is coming from the second quadrant, which is pi minus theta. So pi minus pi on 6 is 5 pi on 6. To get the third solution, it's a full cycle later, so we get that pi on 6 and we just add 2 pi. With the second solution, we just add 2 pi as well, and we get the fourth solution after we simplify the fraction. Alright, so let's just review this. So the first solution is in the first quadrant. The second solution is in the second quadrant, so it's going to be pi minus pi on 6, which is 5 pi on 6. Now, general equation format, you can have the variable to be any letter, so let's switch back to x. For part B, notice how the x has a degree symbol, so we need to have the answer in degrees. Be mindful with your CAS calculator to set your angle to the right units. You can also use a scientific calculator. We'll show you that with the first one. So when you have sine of x equals negative 0.3, it's a negative solution, but just bring it back to 0.3, which is in the first quadrant. So if you're trying to solve the equation sine of x or alpha equals 0.3, use your calculator to find the solution. So what you do is you do inverse of sine of 0.3. That gives you this value, and that value in radian is between that interval from 0 to pi on 2. That value of sine of x is negative for a p. Remember, p is a point around the unit circle. X will be our angle, and it has to be in the third and fourth quadrant. So using the symmetry relationships, we can get with the fourth quadrant, you can get straight away with a negative, but let's go with the third quadrant. So here we have our value. That missing value is 0.3. To get the third quadrant, we just add pi. So we get pi plus our solution. That gives us that amount to 3 decimal places. We can't get that as exact value because it's equal to 0.3. When we do inverse of sine, we get a decimal answer. For the fourth quadrant, either we can take negative 0.3, but the domain is restricted between 0 and 2 pi. So we need to add 2 pi to be within that domain, and we get 5.978. So those are the two solutions for that equation for x to be between 0 and 2 pi. Alright, with the next one, again, it's a negative. Turn it into a positive, solve that equation for a positive value. The angle has to be between 0 and 90 degrees. You use your calculator, make sure your calculator is set in degrees. You get inverse of cos of 0.7. That gives you 45.57 degrees, which is that answer here. To get a negative cos, you need to be in the second and third quadrant. Second quadrant is pi minus theta. Let me annotate that. I should have done that with the other one, but so if that's your theta, second quadrant is pi minus theta, and the third quadrant is pi plus theta. The theta value to get 0.7 is this one. So it's actually alpha. You can rename it alpha. So here is pi minus, for the second quadrant solution, which is negative 0.7, is pi minus alpha. Then here is pi plus alpha. So pi in degrees is 180. Alpha is calculated from above, and we get those two angles solutions. And it is between 0 and 360 degrees. Okay, again, the angles are between 0 and 360 degrees. Do remember in radian it's 2 pi. You need to practice using your exact values. Again, you can use a calculator, but you should know cos of for cos root 3, that's pi on 6. To be a positive, so 1 on 2. So hang on, root 3 on 2. This one is a negative, so turn it into positive to bring it back to the first quadrant. And that needs to be, again, it's the same angle, so it's sine of pi on 6. Okay. This one, negative 1 over root 2. So 1 over root 2, if you rationalize that, it's also root 2 on 2. For cos, it's cos of theta minus 1 on root 2. You transpose the negative root 1 over root 2, that gives you 1 over root 2, so that works out. And it's pi on 4. So pi on 6 is 30 degrees, pi on 4 is 45 degrees. So we have our 30 degrees. There's two solutions. One is, so that's our first solution in the first quadrant. You get also a solution in the fourth quadrant, which is 2 pi minus theta, or 360 degrees minus theta. Wait, I should do the other ones as well, so just give me a sec. Alright, so with the next one, remember for 1 over 2, it's all 30 degrees. So to get a negative value, we need to be in the third and fourth quadrant. So third quadrant is pi plus theta, and in the fourth quadrant it's pi minus theta. When I mention theta, it's coming from or unit circle. First quadrant is theta, second pi minus theta, third is pi plus theta, and last one is 2 pi minus theta, or just the negative theta. Okay. Alright, with the last one, it's pi on 4 or 45 degrees. So if it has 45 degrees, to be positive, it's on the first quadrant as well as the fourth quadrant. First quadrant is all 45 degrees. The last one is 2 pi minus theta, or 360 degrees minus 45 degrees, and we get 315 degrees. Okay, we can generalize that. Is if you have an equation and you have a coefficient on the in front of the sine or cos, or t variable has a coefficient in front, so it's n times t, and it equals to a b value. First thing first is to make cos and sine the subject, so you divide by a, so it will become equals b over a. You substitute nt with x over here, so you're going to have sine of x equals b over a, and then you solve the same way as previously by looking for a solution in the first quadrant. By looking for a solution in the first quadrant and using the symmetries to find if you have any other relevant solution, second, third, and fourth quadrant. Once you find all your x values, you can substitute back by x by nt and divide by n to get the solutions in terms of t. Alright, so with that equation, 2 theta is my 2t, and theta is between that interval, and it equals to that negative value. Okay, so the first thing is you make sine the subject, so there's nothing else to do. Alright, next step is you make x equals 2 theta, so you end up with sine of x equals negative root 3 on 2. Our interval is theta from negative pi on pi. Notice how you're gonna have 4 solutions because the period is pi. So from negative pi to 0 you get a full cycle. From 0 to pi you get a second cycle. And as you draw your line y equals negative root 3 on 2, you have 2 solutions here in the first cycle, followed by another 2. Okay, so you should end up with 4 solutions. Now you're going to do is sine of x equals that equation. Now as you have substituted x equals 2 theta, you multiply this by 2 and you're going to get a new domain. X is between negative 2 pi and 2 pi. Okay, let me get rid of that, my notes. The first quadrant solution is sine of alpha equals root 3 on 2, which is pi on 3. You use your symmetry to find the next one, which is in the second quadrant. Let me think, just give me a sec. So we'll find that one in the first quadrant. To get that negative value, it needs to be in the third quadrant, which is pi plus alpha, and the fourth quadrant, which is 2 pi minus alpha. You evaluate and simplify it, you get 4 pi on 3 and 5 pi on 3, and you can see it's between 0 and 2 pi, which is what we have for y equals sine of x. So here we just change our graph a bit. It's not in terms of theta, it's in terms of x. Okay, so the first the solutions we find are in quadrant 3 and quadrant 4 are those two here. So respectively 4 pi on 3 and 5 pi on 3. To get the other one, what we need to do is, for example, for the one on the left, if we minus 2 pi, we're going to find this one. And that one, we minus 2 pi, and we find the last solution for x. So here is the working out. Alright, now that I clear the screen, you can see the other solutions. You subtract 2 pi respectively, and we get negative 2 pi on 3, negative pi on 3, 4 pi on 3, and 5 pi on 3, and that's for x. Do remember, now we need to go back to what was x originally. It was a temporary substitution of 2 theta. So now for theta, we just divide x by 2, and we get those four solutions. So negative 2 pi on 3, we divide by 2, and we get this one. So that's all we did to actually get to the final solutions of theta. We divide by 2. Alright, and that's it for 14H, and I'll see you in the next video.